Pam, go ahead.
Okay.
Oh, wait, hold on. Let me put that back. Wyatt, go.
Okay, so step one, I read the problem and I decided that step one is to state the hypothesis and identify the claim. And the claim is that the teacher is trying to figure out if the scores of her class are different than the average, national average, whatever. So my claim is that below, yes. Mu is below 515. So my H naught is always equal, so mu is equal to 515, and H1 is my claim, and it's that mu is lower than 515, and that I wrote support next to that to help me later.
Great. And then notice how you put mu is less than 515. Just don't put H1 is less than 515. You have to say what is less than 515. Mu is. Everybody got that? Because a lot of people drop that out, and that's wrong. When someone didn't hypothesize is flat, what does that mean? My hypothesis is flat. Doesn't mean anything. But if you say the world is flat, now that has meaning. Do you see what I'm saying? Okay, good. Joe?
How do I know when you put mu or P?
Is this a mean or proportion?
No, mean. So
Mean, so use mu. If it's a proportion, you would use P.
Okay, and I have to say that I was a little confused by the wording at first because I was wanting the superintendent to try to figure out if her mean or her score was above or below. So I wanted to go with the equals and not equals.
Right.
So-
But she just said below. She didn't say
Right.
she said differs. If she said differs, then you'd use not equal to. Everyone
Okay.
see that?
Okay, so it doesn't matter that she's wishing to see if that
Right.
part
No, it doesn't matter.
Okay.
She only cares if they're below. She doesn't care if they're above.
Okay,
She's only gonna freak out if they're below.
okay,
Do you see what I'm saying?
all right, that helps.
Okay.
Okay. So then step two is to get the critical value and draw a picture. I use the T table to get the critical value because mean Mr. T, and I use the, her sample was 12, so I used the DF11.
How'd you know it was 12?
Because it says she randomly selected 12 student scores.
Right.
So if you look on your chart it's a one-tailed test, we know because it's the arrow is pointing to the left and it's less than. So it's a left tail, one tail test. So you look in your chart, you look under one tail test for 0.01 because it's given in the problem.
Yep.
And then you look for 11, and where it meets is what your critical value is, which is 2.178. Negative because it's left.
Great. Incidentally, I may not tell you how many. If you get a list of numbers, you got to count them. Do you guys see what I'm saying? So you can count them and see that there's 12 there. So on the exam, don't feel like I'm always going to say they selected 11. You may have to count them and figure out what your N is yourself. Okay, keep going.
And I actually did count them to double check,
Yeah.
just to make sure the problem wasn't wrong.
Good deal.
Okay, step number 3. Oh, and then I drew my picture, which you shade in the left part and you put in your critical value. And then step number 3, I calculated my test stat and my p-value. But I use the I use the calculator. And I wrote those instructions up there. Stat test.
Right, so
Sorry,
this will
stat
not get
edit.
full credit. I just want people to be clear, so I'm glad you did it this way.
Okay.
You will not get full credit. I need this. Test stat equals, what was your mean? You gotta figure out what your mean was.
It was
523?
Yeah, 0.08.
0.08.1 minus 515 over S, which was
78.6.
0.6?
Or 5.7.
Five?
Yeah. Well, it was 5.7.
5.7.
And
Six.
6.
Over square root of
12.
12.
Okay.
And then you put whatever that equaled, which was apparently
0.356, I hope.
0.356. I need this. If
Okay.
you want full credit, you gotta give me that. Everybody understand that?
Okay.
So we don't have to do it the other way, right?
You don't have to do it the other way. You don't have to use your calculator if you don't want to. You could just do it this way. But you could write this out and then do your calculator to figure out what this part is.
Yeah, that.
That's totally fine. But I need this stuff here. You gotta prove to me this exam that you know how to find this. On the final, I'm okay with you doing, I don't know, I'm gonna think about that. I'll figure that out later.
Well, and I couldn't remember how to get the X bar and the S, so that was the part, and without my notes, I didn't have that, so I will go back and fix that.
Right, so do you see how she said calculate stat edit, to put in the values? And then she did stat test, t-test, which gave her all that stuff. Gave her the t-value, the p-value, and the mean and standard deviation. Keep going.
Okay, so then I did all that, I got to step number, oh, and don't forget to go put that value up in your picture.
Right.
So you can prove where it's at, which that helps you decide if you're gonna fail to reject or reject the claim. And because your test stat is it is not in the critical region, you're gonna fail to reject. And then you're gonna write your summary. And so there is not enough evidence to support the claim that her test scores were below the national average. I didn't write that down.
Oh, right, there's not enough evidence to support the claim that test scores are below national average. Okay, and you can abbreviate, that's fine. Good. You guys need 15 seconds with your neighbors? Question?
How did you get the P and then what is that for?
The p-value, so you could have compared the p-value to
I never did.
to alpha. So if something is 63% likely to happen, is that unusual? No, totally not. So it's not only was it, if it's less, it should be less than 50%. It's not less than 50%, and then it means it's on the opposite side. It's not even that it was even less than, it was greater than. It's more than 50%. It was really not unlikely at all.
So how do we put that in a calculator just that?
Oh, you did
I didn't
stat test t-test, and you got it, and it gives you your test stat and your p-value, 0.636. So then you can compare the p-value and say it's greater than alpha, if you wanted to. Yeah.
Were we supposed to do that part?
Nope, you're not.
Okay.
Yeah,
Why do they make the critical value negative?
because it's left-tailed. So the critical value is a z-score. If it's less than, all your z-scores should be on the left side. They should be negative.
Okay.
If it's greater than, all your z-scores should be positive. Your critical value should be positive. If it's less than, your critical value should be negative. If it's two-tailed, guys, your critical value should be what?
Positive and negative.
Positive and negative. Exams in 2 weeks, we're gonna do more of these, don't worry. Okay, so don't forget, this is for the two-tailed, two sample means. This is when you find your degrees of freedom. Don't do that big, long, complicated formula, do this instead. We talked about that last class, though, I think everybody's good with that. Using the TI 83, 84 to do stuff. So you can use T interval for intervals. If it's a mean, if it's a proportion, then you would use 1 prop z interval. However, I'm still going to make you find your margin of error and everything else. So this is more of a double check than anything else for you guys. And then for a test, you do t-test and 1 prop z-test. This gives you, this calculates your test stat. And then they call it T or Z depending on whether it's a t-test or a z-test. But like I said before, I'm still going to require that you write the formula. So on the exams, I expect you to do all of these things. State your H0 and your H1. Ideally circle it and let me know it's step 1. Will it affect your grade? Not typically, but if I'm on the borderline between like I don't know that I take off 1 point or 1.5 points, then that can make a difference, right? If it's nicely, if I can find everything. Step 2, say your critical value, draw a picture. How do you find your critical value? They're always going to be looking up in the table in this class. I'm always going to give you a table to find it. Step 3, find your test stat. You don't have to find your p-value if you don't want to. It's up to you. But I need to have all those numbers in the formula and then equals. And then decide, step 4, decide to reject or not reject H naught. So remember, step 4 is all about rejecting H naught. We're doing the entire test to either reject or not reject H naught. So really the whole test is about H naught, rejecting it or not rejecting it. And this is always reject. You guys understand that? Always reject H naught or fail to reject H naught. Make sense? Always. And then summarize results for your claim. So that's going to be support or reject your claim. Someone was curious, they were kind of confused a little bit about this one, right? Because this is supports your claim, rejecting H naught. So both the words are in there, but it's because we're rejecting or not rejecting H naught, that's going to support your claim. So this is about your claim. This is always reject, because we're always about rejecting or not rejecting H naught. So I want to make sure we were clear about that part. Okay, so now let's look a little bit at inferential statistics. We have our sample, we found our X bar and our S. What can we do? We can do one of 3 things. What's the first thing we can do? Kim, read the first thing.
If we don't know mu, we can estimate a confidence interval.
Right? So mu is between this and this. That's chapter 7. So the first thing we can do is we can estimate what our mean is. Chapter 7. The next thing we can do, Simran, go ahead.
If we do know mu, we can find the values of our sample and see how far it differs from mu.
Right. So, yeah, keep going.
Say we want to see if the gasoline additive better gas mileage, so we sample a bunch of cars using the additive and compare their mean gas mileage to the population.
Great. So we want to see if our group is different than somebody else's group. If our gasoline additive works. So we sample a group of people in cars with our gasoline additive, compare it to regular cars to see if our population differs from the regular population. That's chapter 8. That's what we've been doing. Carly, yeah.
So the way to know kind of like the difference between a chapter 7 question and a chapter 8 question is chapter 7 will have a confidence interval and then chapter 8 will have an alpha, right?
Yeah, that's true. Those are true.
Because I was kind of getting confused. On
Yeah.
if
So
it was a-
chapter 7 will always say find the confidence interval or estimate. Estimate is the same as confidence interval. So confidence interval and estimate are the same thing. Same as mean and average are the same thing. Right? So if it says estimate, chapter 7. It says find the confidence interval, chapter 7. If it says you want to do a confidence interval and you want to know what your sample size is or how many people should be selected, that's sort of a confidence interval, but it's a find n problem within the confidence interval within chapter 7. Does that make any, it's a little bit of a special case of that. But yeah, and then these ones will be a test. And we'll look at in next week we'll look at how to tell the difference between those a little bit more. The thing we're going to be doing today is chapter 9. We have 2 samples, 2 different samples, and we're going to compare them to see if they differ. So in other words, you have a test group that got your drug and a control group that got a placebo, and you're going to compare 2 different samples. So let's take a 10-minute break. We're going to start back at 19 after, and we'll start back right away.
Good.
All right, so we're going to be looking at chapter 9 now, which is having 2 samples and comparing them. So everybody grab out your notes for chapter 9 that you just got today. And first we're gonna look at two sample proportions. So the requirements are that they be, well, let somebody else read it. Alejandro, go ahead, read.
Requirements for two sample proportions. 1, you have proportions from 2 independent simple random samples. 2, for each of the 2 samples, the number of successes is at least 5 and the number of failures is at least 5.
Good. The null hypothesis for two proportions. Again, remember null is always no, right? No difference. So in this case, there's a difference between the two populations. So in other words, the first population is the same as the second population. The first population is proportion. So that P does not stand for population, it stands for population proportion. Right? And this is the other population's proportion. So their proportion equals these guys' proportion. It's also written as P1 minus P2 equals 0, because if they're the same, if you subtract them, you should get 0. Make sense? Are you on board with that part? Okay, so there's two differences. The first thing is in the null hypothesis, it says that the first proportion equals the second proportion for the whole population. We also have a couple of things that are going on here. We have something called a pooled sample. This is the formula for it. X bar 1 plus X bar 2 over N1 plus N2. And again, Q bar is 1 minus P bar. You guys are familiar with that part. Here, P is the population proportion. These are your notes, write them down. N is the size of your sample. X is the number of successes. You have a P1, N1, X1, and you have a P2, N2, X2. You should be familiar with these letters here. Here's an example. You guys say there are 20 of you, and 12 of you own a dog. So your P hat 1 would be 12 out of 20. Make sense? Then I sample you guys. And I find out that out of 15 of you, 8 of you own a dog. So your P hat 2 would be 8 out of 15. Everybody on board with that part? If I pull you together, then I'd say, okay, 12 plus 8, 20 of you out of 20 plus 15, 35 of you, 20 out of 35 of all of you own a dog. So you guys kind of on board with that part? So that's what this pooled one is. If you added both of the samples together, what would you get? That's what the P hat, the P bar is, and the Q bar. So you guys do lab problem 1. Find P hat and Q hat, and then find P bar and Q bar when you have these numbers here.